A kite is a certain quadrilateral that has two pairs of adjacent congruent sides. In this case, side AB and BC are congruent, as well as adjacent, while sides AD and DC are also both adjacent and congruent. There are certain theorems or properties that actually make a kite special, and the first one is that the diagonals of a kite are always perpendicular. In this case, that's AC and BD. Secondly, the diagonal that divides the kite into two congruent triangles, which we see on this kite as BD, is actually the perpendicular bisector of the other. And that means that in this particular kite, A, and we'll make this middle point M, AM is congruent to MC. As well as being the perpendicular bisector of the other diagonal, the diagonal that divides the kite into two congruent triangles also bisects the angles. So, for example, in this kite, angle CBM is congruent to angle ABM, and angle ADM is congruent to angle CDM. Finally, we see that the angles formed between non-congruent sides are congruent. In this case, that would make BAD congruent to BCD congruent. Next up, we have the trapezoid. A trapezoid is a quadrilateral in which at least one pair of opposite sides is parallel. Here, as you can see in the diagram, side BC is parallel to side AD. In a trapezoid, some of the consecutive angles are going to be supplementary. In this case, A and B are supplementary, and D and C are supplementary, but B and C and A and D are not. On the occasion that a trapezoid is an isosceles trapezoid, the base angles are congruent. In an isosceles trapezoid, you basically see a line of symmetry. So if this were an isosceles trapezoid, you'd see that the diagonals of this trapezoid are congruent, so in this case that would mean that CA is congruent to BD. Now, if you want to prove that a quadrilateral is an isosceles trapezoid, you have to either use the definition that says that it has one pair of congruent sides, or you have to say that if the diagonals of a trapezoid are in fact congruent, which in this case we see as BD and CA once again, then you know that trapezoid is an isosceles trapezoid. On the other hand, when you just want to prove that a quadrilateral is a regular trapezoid, the only way to do this is really using the definition, which is saying that there's one pair of parallel sides. Next up is the parallelogram. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel and congruent. So here, AD and BC are both parallel and congruent, and AB and DC are parallel and congruent as well. In a parallelogram, you'll see that the opposite angles are congruent. So in this case, A and C are congruent, and D and B are congruent. As well as this, the consecutive angles in a parallelogram are going to be supplementary and add up to 180. So angle A and angle D are going to add up to 180, and angle B and angle C will do the same. In a parallelogram, the diagonals bisect each other. In a similar way to a kite, the diagonal of a parallelogram can cut the parallelogram into two congruent triangles. The difference is that either diagonal can be used here. So AC cuts triangle ABC to congruent to triangle ADC, or diagonal BD can cut it up so that ADB and BDC are congruent as well. There are multiple ways to prove that a quadrilateral is a parallelogram. Firstly, you can use the definition and see that if both pairs of opposite sides are parallel, then this quadrilateral that you started off with is a parallelogram. Alternatively, you can see that one pair of opposite sides is both parallel and congruent. So if you found out that AD was parallel to BC, but not just that, also that the two sides were congruent, then you can also prove that this regular old quadrilateral is now a parallelogram. Also, if you see that the diagonals of a parallelogram bisect each other, like we saw earlier, if you found out that this was the case, then you knew that that quadrilateral is a parallelogram. To prove that a quadrilateral is a parallelogram without using any parallel sides or diagonals, you can use the opposite angles. If the opposite angles are congruent, and that both pairs of opposite angles, so in this case, if angle B and angle D are congruent, and angle A and angle C, then you know that this quadrilateral is a parallelogram.
A rectangle is a quadrilateral with four congruent angles. It has all the properties of a parallelogram that we just explained, but it also has four right angles, so angle A, B, C, and D are all right. The diagonals are also congruent, which wasn't true for a parallelogram. So if you draw a line AC and line DB, those are both congruent. One way to prove that a quadrilateral is a rectangle is that if you have one angle is right. The other way is that if you have that the diagonals are congruent. So if you have that AC is congruent to DB, you can prove that this shape is a rectangle. A rhombus is a quadrilateral with four congruent sides. It, just like the rectangle, has all the properties of a parallelogram, but it also has four congruent sides. The diagonals are also perpendicular to each other, so AC is perpendicular to DB. The diagonals also bisect the angles, so angle A is bisected by AC, angle C is bisected by AC, and angle D is bisected by DB, and angle B is bisected by DB. The three ways to prove that a quadrilateral is a rhombus is that if two consecutive sides of a parallelogram are congruent. So if any two consecutive sides in a quadrilateral are congruent, you know it is a rhombus. Another way is that if the diagonals of a parallelogram are perpendicular to each other. So if you're given that AC is congruent to DB, then you know it is a rhombus. The final way is that if the diagonal of a parallelogram bisects one angle, then it is a rhombus. So if AC bisects angle A, then you know that the quadrilateral is a rhombus. A square is a quadrilateral with four right angles and four congruent sides. So if angle A, B, D, and C are all right, and AC is congruent to AB, which is congruent to BD, which is congruent to DC, then you know that the quadrilateral is a square. It has all the properties of a rectangle, rhombus, and parallelogram, which we just explained. The ways to prove that a quadrilateral is a square is that if one angle of a rhombus is right, then it is a square. Another way is that if two consecutive angles of a rectangle are congruent, then you know it is a square. The final way is that if a quadrilateral is both a rhombus and a rectangle, then it is a square.